Hey everyone, and welcome to another edition of your Advanced Math Notes. Today's topic is right triangle trigonometry. This is Unit 2, Day 3 of the notes. And what's nice about this section of information is that it is mostly a review of stuff that you learned in geometry. So we're going to apply trig to be able to find information about right triangles, and we're going to use SOHCAHTOA primarily in order to do this. So in any right triangle, we need to have at least one right angle, of course, that makes it a right triangle. But any other designated angle, whether it's designated with a theta or some other variable, or an actual angle measurement, and we'll always be using degrees for problem solving with right triangles, which is going to be nice. So using that angle as a reference, the side that's across from it, the leg that's across from it, is the opposite side. The side that is next to it is the adjacent side. And of course, the side that's across from the 90-degree angle is always the hypotenuse. So that's set no matter which angle we're looking at. So the easy way that I have of never messing up my opposite and my adjacent side is I actually take a finger and I put it on top of my angle measurement or my theta. And the side that I'm touching is always the adjacent side, and the side that I'm not touching is the opposite side. Again, the hypotenuse is always the side across from the 90-degree angle. So based on that information, then the sine of that angle is the opposite side over the hypotenuse. The cosine of that angle is the adjacent side over the hypotenuse, and the tangent is the opposite side over the adjacent. To memorize this, in geometry, you learned the word SOHCAHTOA. S-O-H for sine opposite hypotenuse, C-A-H for cosine adjacent hypotenuse, and tangent, or TOA, for tangent and opposite and adjacent sides. Of course, this year we're also going to add to that cosecant, secant, and cotangent, which are the reciprocals of sine, cosine, and tangent. So therefore, cosecant is the hypotenuse over the opposite side, secant is the hypotenuse over the adjacent side, and cotangent is the adjacent side over the opposite side. So we're going to apply all of that information to solving right triangles, as well as to evaluate trig functions within right triangles, not just on the unit circle. And the last piece of information that we need to review is angles of elevation and depression, because we're going to see a lot of triangles, right triangles in the real world that we're going to evaluate different sides and angles for, and a lot of them have to do with angles of elevation and or depression. So the key thing to remember with an angle of elevation or depression is that it always has to include a horizontal line. So if you're standing above what you're looking at, or if whatever it is above the other thing, like so if you're from the point of view of the higher elevation, then it's going to be an angle of depression because you're looking down at something. Whereas if you're at the bottom and you're looking up at something, that's considered the angle of elevation. And it's always formed with the line of sight or the horizontal from wherever the initial object is. Okay. Angles of elevation and depression are always congruent within the same situation, because they are what we call alternate interior angles that are formed by a transversal that cuts through parallel lines, the two horizontals. And as you learned in geometry, alternate interior angles are always congruent to each other. So if a problem asks you to find an angle of elevation, you could also find the angle of depression and it would be the same, or vice versa. So we create our right triangles this way by using the horizontal, the angle either looking down or looking up, and then the vertical line from the higher object straight down to the ground, wherever that might be, or from the lower object straight up. And we create two identical right triangles that will then apply our trig functions to find missing side lengths, distances, heights, or angles, angle measurements within. And again, for all of this problem solving, we'll get to use degrees, since we're applying it to real world problems and not just theoretical math problems. So yay, it should be a pretty easy section. Hopefully it's mostly a review, but come next class with any questions that you have. We'll go over them as well as take a look at some of the types of problems that you'll see in this section. Have a great night.